Hi class, the problem today is from chapter 14, which is our chapter on competitive markets. These are often called purely competitive or perfectly competitive markets. Let's see here. The problem that I want to work is number 7 at the end of this chapter. That's going to be on page 286 of the textbook. So in this problem, we're going to be given some information about some hypothetical firm, some cost, some revenue data, and then they're going to ask us a series of questions. So let's see here. Question says that this firm is profit maximizing. It's in a competitive market. They're currently producing 100 units of output. It has an average revenue of $10, average total cost of $8, and fixed costs of $200. So straight away, a good practice is to take all that information that's given to you in the problem setup, right? Oftentimes, the practice is going to be to take some given information, take some fact that you know to be true about a particular scenario. What do we know about perfect competition? And then from that, sort of combine those two pieces of information. All right, so all I've done here to get us started is to just first glean or pull from the problem setup all that information that they told us. The quantity is 100, their average revenue is 8, average revenue is 10, average total cost is 8, fixed costs are 200, and that the firm here is operating in a competitive scenario. Okay. Question A then is going to ask us, all right, what's this firm's profit going to be? Okay, stand back, ask yourself, well, what is profit? How's that calculated? This is an easy one. Profit, remember we abbreviate that with the symbol pi. That's going to be the difference between total revenue, all the money that the firm collects, and total cost, all the money that they're spending. Okay, that's the definition of profit. Let me stand over here. All right, so then we got to figure out each of these individually and then put them together. So let's start with profit. Profit is always going to be price times quantity. It's another way that you could rewrite that. Just take the number of units that you sell, which is the quantity, and multiply by what you get for each one, which is the price. And then that total cost can be rewritten as the quantity times the average total cost. Right? The number of units that you make multiplied by how much it costs you to make each and every one. So there we go. Rewriting profit like this is useful for us because check it out. The problem is already giving us a whole bunch of these variables. And we can infer the other ones really easily. All right, so let's start here with the price. How might we get the price from this information? They don't give us price directly. Here what you want to do is to recall that in perfect competition, firms face that horizontal demand curve. So it's true that the price is the same thing as their marginal revenue, same thing as their demand, same thing as their average revenue, which is given to us. So that average revenue of 10 tells us that the price must also be equal to 10. All right, so I'm just going to pull that over here. Right there. They're going to charge a price of 10 for each and every unit that they sell. How many units are they going to make? How many are they going to sell? Well, the quantity is given to us as 100. There we go. So we're on our way. Price times quantity. How about the other stuff? Well, this is directly given in the problem. So that quantity is the same. It's going to be 100 units times an average total cost of 8. There you go. Your setup is all good to go for getting the profit for our firm. Real quick now, you can probably eyeball this. That's going to be $1,000 of revenue coming in minus $800 of costs going out. Means that the firm in this case is going to be left with $200 of profit. There we go. A is all done. We're on to the next one. Okay. Question B is asking us, what's the marginal cost for this firm? This is a little bit trickier to find, but we can see it when we remember what the graph looks like for a firm like this. Lots of times you'll encounter in this chapter a graph. It's going to look like this. Dollars on the vertical axis, quantity on the horizontal axis. Here's your horizontal demand curve equal to marginal revenue and average revenue and the price. And then you see a marginal cost curve that's upward sloping like this. So we know this is the graph that's appropriate because the problem tells us it's a competitive market. We're looking for the marginal cost of production when they're producing 100 units. The key logic here is that the firm says in the question setup is going to be a profit maximizing firm. That tells us which quantity they want to produce. They want the one that's going to give them a result that looks just like this picture. In other words, such that marginal cost equals marginal revenue. Right? Producing that particular quantity is going to maximize their profit. We'll check it out. The marginal cost is what we're looking for. The marginal revenue we already found in the beginning of the problem. That marginal revenue is equal to price is equal to average revenue. And so the short answer to our question here in B is that the marginal cost must be equal to 10, right? Because it has to be the same as that average revenue, this firm's profit maximizing. All right, on to question C. Okay, can you see this over here? Tilt this a little bit. There you go. On to question C, where they're asking us, what's the firm's average variable cost? Okay. Logic you want to use here is that all the costs that they have, that total cost, is equal to the sum of fixed and variable. Let's see if we can sort of pull those out from the question setup. Let's see. Total cost of production, we found that earlier, didn't we? Yes. The total cost of production was 800. From the beginning of the problem, quantity times average total cost. Given to us in the problem setup is the fact that the fixed cost there is equal to 200. Right? So we just need to add to these fixed costs, whatever the variable costs are, to get to that $800 of total cost. Well, we can do some real quick math there to see that the variable cost for this firm is going to be equal to $600. Finally, then, the question's going to ask us about the efficient scale. Is this firm here operating at their efficient scale? And if they aren't, is the efficient scale going to be more or less than 100 units? Okay. Here's one where I think a graph is really useful. So I'm going to erase what we've done. Get the picture here on the board. Set it up like so, quantity in dollars on your axes, horizontal demand curve, because this is a competitive market. Demand is equal to price, it's equal to marginal revenue, it's equal to average revenue. You can put it over here or over there. I've seen both, no real significance to that. Okay, let's see, we want the firm's marginal cost curve looking like this. We know the profit maximizing output is 100 units, and that 100 falls right underneath that intersection. And then finally, let's see, we know that their average total cost curve falls down here. Right, we know that because their average total cost is given as 8, whereas the price was given as 10. So they're getting some positive economic profit when they produce. Now that we've got the graph, we can answer the question in D. The question is the firm operating at their efficient scale? Efficient scale means you're operating where the average total cost is minimized. Right? You're producing in the most cost-effective way that you possibly can. Are they doing that here? We can see, no, that they're not. Right? The way that they would minimize their costs is to produce this quantity right there, right, where the marginal cost crosses through the average total cost curve. However, because this firm has positive economic profits, the average total cost of 8 is going to be higher than this lowest possible average total cost. Right? And so the conclusion that you want to draw then is that this firm is not, in fact, operating at their efficient scale. In fact, they're producing more than the efficient scale. The efficient scale would fall short of 100. Right? So again, this is one, like a lot of the problems that we're working, where to get to the right answer, you're really combining many different ideas that we've been learning about throughout the class. So there you go. Hope that's helpful for you. I'll see you next time.